rate problems. So this is kind of a classic algebraic problem. If mom or dad or a grown up at home is kind of watching over your shoulder, they're going to see this problem and go, oh, it's that kind of problem. This is kind of the nemesis of those of us working through algebra. So here's our problem. Two trains leave the station 60 miles apart at the same time, heading toward one another on parallel tracks. That's very important. Train A is traveling at 30 miles per hour, while train B is going 50 miles per hour. When do they pass each other? So the problem here is that they're going different speeds. If they were going the same speed, we could just say right in the middle, be done with the problem. But they're not going the same speed, which kind of creates that, well, when will they meet here? Since train A is going a little bit slower, it's going to be closer to train A than it is going to be to where the station where train B left. So when we think about this, we're talking about moving here, we're talking about a distance, we're talking about their rates. So we want to think about our distance equals rate times time. And any of these problems where we have rates going, I find one of the easiest way to start to organize your information is by making a table. So I always set up a table with the different things that I have going on. In this case, I have train A and train B. And whatever my rate is that I'm working with, I kind of use the rate and then kind of tear it apart for the rest of the columns. So I have my rate as miles per hour, which means I have one column that's miles, and I have another column that's hours. So if that was meters per second, I could do the same thing. And for any type of rate, if I had dollars per hour, I could do dollars per hour, I could do a column of dollars, and I can do a column of hours. So I can really use this for any type of rate that we're looking at. So I'm going to think about what's going on with these two trains. Now, whenever I have the two train problem, I like to draw a picture to kind of see what's going on here. So we've got train A, and it's going towards train B. We've got train B, and it's going towards train A. And the distance between the two is going to be 60 miles. So the distance that they both collectively together have to cover is going to be 60. Notice A is not going to go the full 60 miles, and neither is B, because they're going to meet somewhere in the middle. What I also want to think about is the time. How does the time compare for each of these trains to each other? And notice what's happening is that they're leaving the stations at the same time, and then they're meeting at the same time. Which means if I had a stopwatch going, I could start the stopwatch when they left the stations at the same time, and then I could stop it when they met. So their times are going to be the same. So what I'm going to start to fill in here are their times. I know that the time that train A is going to be traveling is the same as when train B is going to be traveling. And since I'm looking for the time, that works out perfectly that that's my variable. So I'm going to plug T in there, T for the time that they are traveling. I'm then going to plug in their rates. So I know that train A is going a little slower. It's going 30 miles per hour. And train B is going a little faster at 50 miles per hour. And once I have two columns filled in, I can really spread this across to the third, because I know that rate times time equals my distance. So the distance that train A is going to be traveling is 30 times its however long it's traveling. I don't know that. And train B will be going 50 times T, however long it is traveling. Again, that's still our unknown. So I have their distances. I have expressions for each of their distances. That works out so far. And again, we said that their two distances together should add up to 60. So I can write an equation that says train A's distance plus train B's distance should be equal to 60 miles. I can then solve that equation, and I come up with 3/4. My 3/4 is of an hour for my time. So each of these trains is traveling for 45 minutes to get to a place where these meet. Now, rate problems have a lot of different variations on them, so you'll have to try to wrap your brain around each particular situation. Sometimes we have the trains going in the same direction. Sometimes they're not leaving at the same time. Sometimes we're trying to find a distance and we know their times and their rates. So drawing a picture, I find, usually helps. Sometimes actually moving it out, I find helps. And setting up a table to organize our information.